Hello class, I hope everyone's doing well when they start watching this video. We're going to be going over friction today. So we've learned or talked a little bit about what the friction force is, but we're going to look at it a little bit more in depth today. So I wanted to start by doing a quick review. So if you guys would want to just pause this video and think about each one of these questions as we go through them, I think that would be great. Just to kind of review what we've been learning about and make sure we're just seeing the information another time. So the first question I have for our review is, what is acceleration? So we learned that acceleration is a formula, and we could find acceleration by taking the change in velocity and dividing it by time. Our next question here is, what does a distance versus time graph look like for acceleration? So we were practicing these during our Zoom call on Monday, what our distance versus time looks like now with acceleration. And we said that if something is accelerating, if something is getting faster and faster and faster, we have a little curve up. If something's decelerating, we kind of have this curve, but kind of going flatter like this. So just some good review to get us thinking about friction today. Our questions are, what do we already know about friction? We've quickly talked about a friction force, and maybe we have experienced friction a lot in our lives, and so what do we already know? What happens when something has a lot of friction? So let's say we're trying to push against something. What happens when there's a lot of friction? Of course, it slows down. And then another interesting thing is when we have a lot of friction, things heat up. So friction, if we rub our hands together even, we can feel our hands getting warmer. And that's because we're working against that friction force, and it ends up heating up our hands. Kind of an interesting thing that happens. So our objectives by the end of the day is to understand what friction is and the factors that affect it. We also want to be able to give an example of how friction is used. So this video will be linked in our classroom as always. I think it's kind of a interesting, kind of fun and good explanation of how friction works. Only a 2-minute video, so real quick. But some of the basics that we're going to learn about, first the definition. So friction, or a friction force, is the force that opposes motion. That's going to be our most important definition. It opposes or goes in the opposite way of the motion or the direction that we're going. Our friction will change depending on the types of objects that are touching each other. So friction has to happen between two objects that are working together, or I should say working against each other, that are touching. So our friction has to be between two objects, and depending on those objects, the amount of friction will change. So, for example, we've all noticed that sometimes when we step on a wet floor after mopping it, it can be really slick. And that's because the friction of the floor is very low. There's not much friction. And so sometimes it's so slick that we can fall on the ground. Lots of different things happen. Or we've noticed maybe if we're walking through or walking across a lot of rocks, there's a lot of friction there. So it can be hard to push a wheelbarrow maybe through a bunch of rocks, or even walk through a bunch of rocks because there's a really high friction force. So there's two things that affect the amount of friction we have. The first is the type of the surface of the object, and the second is the weight of the object. So we're going to go through each one of these things that affect friction, but I want to show you guys a couple of simulations first. So all right, we're going to go through friction. So the very first thing we have is a similar simulation to what we've done before, and it has to do with friction though now. So if we have a lot of friction, we can slide this bar up, or if we have a little bit of friction, we can slide it down, and we can see if we have 0 friction, it turns to ice, because ice does not have much friction. And as we turn it up higher and higher, we can see the surface kind of changing just a little bit. Just maybe it looks like it's just getting a little bit more rough. So we're going to leave it, let's start with no friction. So let's say if we have no friction and we're going to put an applied force of 50 newtons, we can see our applied force is 50, our sum of forces is 50 because there is no friction force. There is nothing opposing what we're doing. As I start to increase our amount of friction here, I can get it to where our friction force is equal to our applied force. So our sum of forces is 0. Let me reset this. And when that happens, we have 50 on one side, 50 on the other, and we learned that our net force or our sum of forces would be 0 because we have 50 newtons of applied force going to the right and 50 newtons going to the left. And so our sum of force would be 0, we wouldn't be moving. As I put more friction force on this, let's make it lots, it's going to, if we have a lot of friction, there we go, let's go back. Okay, so we have a lot of friction. Right now it's equal, so we're not moving. Our friction force is equal to our applied force. As I go up, our applied force is 100, our friction force is 100, our applied force is 150, and our friction force is 150. So we have so much friction that even by putting this much applied force on it, it won't move. Now eventually we'll put so much applied force that we will get it to move against our friction, but it just takes a lot more. 200 newtons isn't enough, 150. It takes up to 300 newtons. Actually, it looks like 200 is the number. And our friction force, the best we can make our friction force be is right now is 188 newtons. But what happens if I put a box on it? Suddenly our friction force gets a lot bigger. We just doubled. We went from 50 kilograms to 100 kilograms. And so our friction force got a lot bigger because we have more weight. So we can increase or decrease our friction force by the amount of weight we have or by the type of surface. So as we change our surface type to go back to ice, we can put as much weight as we want. There's no friction. We cannot change our friction force anymore because we have such a smooth surface. There's no. So that's our first simulation. Our second one shows a molecular view of what happens when we have friction. So we have two books together. We have our chemistry book on top and our physics book on bottom. And what I'm going to do is move the chemistry book and see what changes. So I can pull it apart a little bit. As soon as I touch them together, drag them, we can see our thermometer is going to change. We're going to produce some heat by doing this. We got really hot and our particles started to move together, or started moving because there was more energy in our system. Eventually, it can get so hot that it would push the particles off to the side. But the idea is a lot of different objects kind of have this, kind of almost looks like mountains or hills when we look this closely at it. Not everything is perfectly flat, even though it may look that way. Everything has some different molecular structures or different ways that they look, and so if we had something that had a lot of mountains, a lot of hills, it would be rougher or have more friction than something that is nice and smooth. I just really wanted to show you guys, as we drag things across, we can see our temperature goes up and that our particles start to move a little bit more. So let's get rid of those. Alright, so we have another demonstration that explains this friction, I think, in a good way. So we're going to watch a video of two blocks getting put on an incline. Of course, like anything, gravity wants to push our blocks down the incline. But our friction force is going to oppose the force of gravity. So gravity is pushing us down. Our friction force is going to be pushing us or keeping us where we're at. So we're going to put three different things. We're going to have one with a block that's just normal, a block that has aluminum foil on it, and a block that has a sponge on it. And I want you guys to think about which one do you think is going to fall or go down the ramp first? The one that is normal, the one that has aluminum foil, which is a little bit smoother, or a sponge, which is very rough? So let's watch this quick video. And I'm going to skip ahead. So this is his example. He's just going to show as he raises it up, this one falls. But now he's going to try our 3 different ones. Okay. So our aluminum foil goes first. And then finally our sponge. So we had, that just showed us that our first force, or our first thing that affects our friction force, is our surface area. So the one that is the roughest, that has the most kind of hills, kind of bumps on it, is going to have the most friction. And the ones that's the smoothest will have less friction and go down faster. So our types of shapes matter as well when we talk about this surface type. So we can all picture this when we have a ball on a ramp. It's going to roll and want to roll a lot more than if we had a box or a block like we just showed. Then that's because we have more contact on our box. So our box looks like this. We have a larger contact area, or more of our box is touching more of our little incline, versus when we have our ball over here, or our circle has a smaller contact force, or the less of it's touching the object, and so it has less friction, so it can roll better. Now let's look at our weight. I don't think we have a video of this, but the idea is if we put a stack of books versus one book, which one would be harder to pull or push or move? Of course, if we have a stack of books, there's going to be a heavier weight on that, and so our friction force is going to be higher. And you guys maybe could try this on at home by yourself. When we have that happen and we're trying to push against a large stack of books, our friction is very high, and so the more the weight, the more the friction force we feel. So some fun examples. Friction opposes movement, but it's also really important for our life. It's really important to move things. So if we didn't have friction, we couldn't walk. Have you guys ever walked on a slip and slide? And it's very hard to walk on it or without falling because there's so much friction. There's not much friction. There's almost no friction, that when we step, our feet slip instead of gripping and being able to push. So friction can be really important as well. And so this is a fun video that I will link in our classroom at well, which just explains what would happen if we had no friction in the world. Post that next to our thing. But our exit ticket, one thing I just want you guys to think about is what is one example of a way friction is helpful in our lives. I think too often friction makes things harder. We have to work harder to move something, to push something, because there's a lot of friction on it, but that's not always the case. So what is one way friction can be helpful in our lives? That is all I have for you guys today. I hope it makes sense so that we understand friction a little bit better now. As always, if you have questions, please let me know.